Now, our next guest. AI is a buzzword we all hear frequently, especially in the context of giants like Google. And the specifics of what exactly they're doing are not clear to everyone. So to shed light on this fascinating area, I'm thrilled to introduce Lior Stern, who leads Google's endeavors in AI for healthcare. Please, Lior.
Thank you, Amalia. I'm very happy to be here with all of you today to talk about AI and large language models in the service of health. I am fortunate enough to have been working at Google for a long time. I should introduce myself. My name is Lior Stern, and I'm responsible for product management for Health AI at Google. As I said, I've been working at Google for a long time, and in everything I've done, including bringing Google to Israel almost 20 years ago, when things were busy or stressful, I would always joke and say, hey, it's not like we're saving lives here or anything. Thank you. One of the things that I value most about my current role is the opportunity to harness technology to improve the accuracy, availability, and efficiency of healthcare. But before we talk about artificial intelligence in healthcare, let's look at the field in general first. As Amalia said, artificial intelligence is a buzzword. It's everywhere today. It's everywhere here with us at MIXI today. And AI is revolutionizing industries. From economics to agriculture to medicine, AI is what generates recommendations for you when you open YouTube or Netflix. It is what helps you get the most accurate search results when you do a Google search, and it is becoming better and more capable over time, especially in the last 2 years. So what is artificial intelligence? AI is the simulation of human intelligence processes by computers, which enables computers to perform complex tasks that were previously only doable by humans, such as reasoning or problem solving. This creates systems that are capable of learning and improving over time, and ultimately can outperform any individual human in certain tasks. One of the concepts that we all hear, especially since the arrival of Bard, which is now called Gemini, or OpenAI's ChatGPT in our lives, is LLM, large language models. What does it mean? A large language model is a system that is trained on massive amounts of data, which allows them to learn the statistical relationships between words and phrases, for example. This enables the models to generate text, translate languages, produce different kinds of creative content, and answer your questions in an informative way. You can think of LLMs, in short, as prediction engines that are working with vast and increasing data sets. Just by show of hands, can I ask folks to raise your hand if you've used ChatGPT or Google's Bard or Gemini? Okay, so I think almost everyone here. If you've used one of these products, you know that you can ask it factual questions, and it'll be able to retrieve and synthesize content from different sources to provide an answer. On the other hand, you can also ask it to perform specific generative tasks, such as writing a LinkedIn post for you or summarizing an article. Let's take Gemini, Google's most advanced large language model, as an example. Gemini can understand the world almost like people do. It can take text, audio, video, and images and generate a variety of outputs. It can read very long text and analyze it. It can help us think of ideas for how to plan a birthday for our children. It can come up with a creative solution for a presentation we're giving, or it can help a student prepare for an upcoming test, as well as many other diverse uses. Another example is Imagen. Imagen is a type of large language model that can take text prompts and generate hyper-realistic images from it. Each of these images behind me, although not all of them are super realistic, was created by AI using only the text prompt that you see under the image. So naturally, the question arises as to how these models can be used for the benefit of specific fields. In our case, the healthcare field. We at Google have been working on this issue for quite some time now, and we're trying to understand how we can create different uses for language models that will be able to help everyone involved in health: patients, clinical teams, hospitals, governments, insurance companies, etc., improve existing capabilities, save time and money, and most importantly, bring about better health outcomes for everyone. So I want to introduce you to Google's Health AI effort, and then we'll talk through a few examples of how we're applying LLMs to advance healthcare. Health AI is a Google research team that's focused on catalyzing the adoption of human-centered AI in health in order to make care more accurate, accessible, and affordable for everyone. We think of our constituency, we talk about our constituency as the 3 Cs: consumers, caregivers and researchers, and communities. And I'll give you a few examples of how we work with each of these. Google is a part of a lot of people's lives, and health is a vital part of everyone's life. So what we try to do is look at the products people use every day and ask ourselves how we can make them more helpful to people's health journeys. For example, by leveraging the sensing capabilities of wearables or mobile phones to help you understand your personal physiological data. We also know that information is a determinant of health, and so we work across Google Search, YouTube, Google Maps, and other products to engage people in their health journeys and address address misinformation. And increasingly, we see AI unlocking powerful ways to help people find health information. Sometimes describing an odd mole or a rash on your skin can be hard to do with words alone. Fortunately, Google Lens offers the ability to search skin conditions that are visually similar to what you see on your skin by just taking a picture or uploading a photo, and you'll be able to find visual matches to help you along your search. This feature also works with other things on your body that you may not be sure how to describe, like a bump on your lip, or a line on your nails, or hair loss on your head. For caregivers and researchers, we've developed AI-powered diagnostics that are inherently data-driven and which include a feedback loop to reduce errors and biases over time. This leads to superhuman accuracy, especially for making diagnoses from complex medical images like mammography and CT scans. As we will see in a couple of slides, AI and large language models in particular are also great for streamlining medical tasks such as question answering and summarization. Lastly, AI can be extremely valuable as a tool for experts. For example, in pathology, the differences between benign and malignant tumors are subtle, but we found that the combination of pathologists and AI tools jointly assessing each case was actually more accurate than either alone. At the community level, AI can improve disease surveillance and population-level hotspotting. In South Africa, we've partnered with screening programs to improve the detection of tuberculosis from chest x-rays. AI can also give countries and ministries of health new ways to increase the scale of their screening programs, such as in India or Thailand, which lack enough eye specialists to screen widely for diabetic retinopathy, a leading cause of blindness. Our AI tool enables healthcare to screen 40 patients an hour for the disease, and all told, we've screened more than 300,000 patients worldwide. A great example of the application of LLMs, or generative AI, to the field of medicine of healthcare is MedPalm, a large language model designed for the health domain. As we just saw, progress in AI over the last decade has enabled it to play an increasingly important role in healthcare and medicine. Breakthroughs in neural networks have enabled large language models to scale to billions of parameters, letting generative AI move beyond limited pattern recognition and into the creation of novel expressions of content, from speech to scientific modeling. Developing AI that can answer medical questions accurately has been a long-standing challenge with several research advances over the past few decades. While the topic is obviously very broad, answering U.S. medical licensing exam, USMLE, style questions has emerged as a popular benchmark for evaluating question answering performance. Here's an example of a USMLE style question. It is a vignette containing a description of the patient, symptoms, and medications. Answering the question accurately requires the test taker to recall facts about symptoms, examine findings from patient's tests, perform complex reasoning about the likely diagnosis, and ultimately pick the right answer for what disease, test, or treatment might be most appropriate. In short, a combination of medical comprehension, knowledge retrieval, and reasoning is necessary to do well here. It takes years of training for clinicians to be able to accurately and consistently answer these questions. In the U.S. medical licensing examination, the passing score for students to become doctors is usually 60%. But even world-leading AI labs using the very latest large language models were seeing performance plateau between 45 and 50%. Our first version of MedPom reached a passing score of 67.6%. Our second version of the model, only a few short months later, reached 86.5 on the USMLE, exceeding any other medical large language model and attaining expert-level performance at the test. The next project I'd like to talk about is AMY, Articulate Medical Intelligence Explorer. Recent progress in large language models outside the medical domain have shown that they can plan, reason, and use relevant context to hold rich conversations. In healthcare, of course, the physician-patient conversation is a cornerstone of medicine. Skilled and intentional communication drives diagnosis, management, empathy, and patient trust. AI systems capable of such diagnostic dialogues could increase the availability, accessibility, quality, and consistency of care by serving as useful conversational partners to clinicians and patients alike. But approximating clinicians' considerable expertise is a significant challenge, on which relatively little work has been done. So inspired by this challenge, we developed AMY, a research AI system based on a large language model and optimized for diagnostic reasoning and conversations. AMY is a language model that can not only retrieve data from a medical database, but a system that can simulate the conversation that takes place between a doctor and a patient. Of course, such a conversation involves much more than just the exchange of medical information. There is the need to ask the right questions in the right way, to draw conclusions, and to incorporate elements of diagnostics. We trained and evaluated AMY along many dimensions that reflect quality in real-world clinical consultations from the perspective of both clinicians and patients. We tested AMY prospectively in real examples of multi-turn dialogue by simulating conversations with trained actors. We then had specialist physicians evaluate the transcripts of those consultations. In this setting, we observed that AMY performed simulated diagnostic conversations at least as well as primary care providers, and even had greater diagnostic accuracy and performance in 28 of 32 axes evaluated by the clinical specialists. Now, I want to stress that this is an early research project. In fact, we just published the paper on AMY in January, but the results are promising, and for our purposes today, I think this is a great demonstration of what could be possible in the application of generative AI in health. My last example is about Fitbit, Google's consumer health and wellness service. Fitbit's mission is to help everyone in the world become healthier. A decade ago, consumer health devices were primarily limited to basic step trackers. And health data was fragmented across different systems and devices, making it difficult for users to gain a good understanding of their overall health, as well as how to take action to improve it. Today, the landscape of consumer health devices has evolved to users having access to a wide variety of connected devices that measure a wide range of health metrics, from heart rate to sleep to fitness activity and even ECG. There's also a growing shift towards personalized health solutions which empower consumers with access to data from diverse sources, such as wearables, of course, but also blood pressure cuffs, continuous glucose monitors, lab test data, and genomic data. This combination of information sources enables additional insights and motivations that can assist in preventative care. And innovations in generative AI will only accelerate these trends in the coming years. Last year, we announced a new concept called Fitbit Labs. With Fitbit Labs, we will be introducing generative AI-powered personalized capabilities in the Fitbit app and bringing those to Google's users. These include the ability to surface insights, connections, and correlations found in your Fitbit data. Utilizing large language models, we will be able to bring you personalized coaching and dynamic workout recommendations with rich context and insights, as well as the ability for users to ask questions about these insights, such as, why am I getting less sleep than usual, or help me understand why today's run was harder than yesterday's. And I will end with this. At Google, our entire approach to AI is based on two values that go hand in hand throughout the process. On the one hand, to be bold and groundbreaking, and on the other hand, to act responsibly. This is always true wherever innovative technology is developed, but it is especially true when we talk about technology in the healthcare world. Therefore, we want, on the one hand, to push the boundaries of what is possible and build systems that can create significant positive change in the health and lives of people while acting responsibly at the highest levels at all times. Thank you very much.